Beyond layer 7, content monitoring, layer 1, hardware, data, layer 2, data link, and all the way up to layer 7. What's at layer 7? We got content. Well, back in the day, we had layer 3 and 4 firewalls, and so we were monitoring traffic based on ports, IP addresses, and we're letting everything go out that our users want to do. We're letting just a little bit come in. But we can get around this if we reuse a well-known port like port 80 to do something other than HTTP, or we piggyback on HTTP. And we can also do other stuff to get around it. On layer 7, if we want to do filtering there, this was a newer thing that's been done over the past 10 years or so. We dig deeper into the packets, we figure out what the protocol really is, and we don't care what the port number is if we're talking about TCP/IP. It's easy to get around that too. We can encrypt the data, we can encrypt the packets using SSL. It's the easiest thing to do. We can do TCP tricks. Boy, this 15 seconds is really short when you're up here. So we get down to content filtering, and that's what my company's been doing for the past several years. Not my company, I'm sorry. It's Doug's company. We recognize the application protocols. We reassemble these TCP segments into the whole content streams. And the neat thing is we're doing this all on an open source base. We've used FreeBSD, Apache Postgres. We're not using LAMP, we're using FAMP, or FAP rather. All these great projects that people are making available freely. And why did we pick FreeBSD? Everybody asks, well, why aren't you using Linux? Well, it's got a friendly license, good network stack. I've got a lot of experience with BSD. And I've got a lot of experience programming on BSD in the kernel and the user land, so it's a good base for our product. Why Postgres? That's our database system. It's got a friendly license that, like FreeBSD, allows you to use it without having to pay for it. It's got a rich feature set. It's scalable. We can scale it up to terabytes if we want. So what's our challenge with inspecting content? We want to look at emails and see when people are trying to sneak stuff out, like credit card numbers and stuff like that. We've got high packet rates, connection states. We've got a lot of I/O bandwidth. We've got a lot of stuff going on that we have to juggle. So our content inspection solutions, we've got device pooling, multi-threaded packet processing from FreeBSD. We have efficient object allocation, deallocation. So we've taken advantage of a lot of free software to do what we need to do. Then we take advantage of more FreeBSD features. We memory map files. We use lots of memory, which has been a feature of these AMD 64 processors and the Intel processors that do the same stuff now. What we need to do is find out what people are communicating to each other, and we pull the text out of it and then try to match it in all these different ways so we can figure out what people are doing. And we find credit card violations, social security number violations, proprietary information that's sneaking out. We've replaced our GUI with a web-based GUI that's based on Apache, PHP, and Flex. We've leveraged PHP classes. We've got a Smarty template engine, so we can do the model view controller kind of model for our web applications. We are using some Ajax, and we also put in a lot of work into the context-sensitive help lately. So what we've got also, we've got some real-time features in we're making use of Adobe Flex. And, you know, I wrote this slide before today, and today, Adobe open sourced Flex. So, one more thing. We're giving back. We've given back bug fixes to FreeBSD. We've found bugs and fixed them in LDAP libraries. We help other open source users. We're involved in lots of different email projects or email support groups. And as a result, what we've got is products that are out there and we're selling them, we're making money off of them, and the products couldn't be where they are without these open source organizations. Wow. Hey, I can start over. All right, thanks.